Okay, in this second video, we're going to determine whether or not a series converges absolutely or conditionally. And these notes can be found on the top of page 11. And basically what it says, if the series would have converged, even if it had not been alternating, then it is said to converge absolutely. So what we want to do is we're going to say, okay, if it had not been for the alternating part, would this series have converged? And the answer to that is yes, then we say it converges absolutely. If the only reason the series is converging is because it's alternating, then we say it converges conditionally. Now, that seems to be a difficult concept for kids to grasp, so I'm just going to go over a couple here, and then we will review this again tomorrow in class. Okay, so, sorry I'm back. I just wanted to make a little bit more room for doing these. Okay, so the first thing we need to determine, is it alternating? And yes, this alternates because of the -1 n plus 1. Then the next thing we want to do is determine what is the limit as n approaches infinity. And we can see that that limit is 0. So it's alternating, the limit is 0, does it meet the criteria of 1 over n plus 1? Is that less than 1 over, less than or equal to 1 over n radical n? And I'm pretty sure it is, but if we want to look at it, it's n radical n is less than or equal to n plus 1 times radical n plus 1. So we can see that this is smaller, so this converges. And it converges by the absolute value, alternating series test, okay? So it converges. Now the question is, would 1 over n radical n, would this have converged on its own? If it had not been alternating, would this still have converged? That's our question. And the answer to that question is yes. Why? It's the p-series. It's 1 over n to the 3/2. So p is greater than 1, so this would have converged anyway by p-series. So because it converged because it was alternating, but even if it had not been alternating, it still would have converged, we say that this converges absolutely, or it absolutely converges, because it would have converged even if it had not been alternating. Okay? Let's look at the next one. Once again, this causes this to alternate. Okay? This is making it alternate. So our next thought is to take the limit as n approaches infinity of 2n plus 3 over n plus 10. Now, what is the limit of this? I think the limit of this is 2. So this diverges by the alternating series test or by the nth term test, either one I'd accept. But this diverges because the limit is not 0. Okay, so we're going on to the next one. So once again, this part is causing it to alternate. So we don't look at it. So we take the limit as n approaches infinity of n to the 1/4 power, negative 1/4 power. And we know that this limit is 0, so it meets the first criteria. Does it meet the second criteria? So does 1 over n plus 1 raised to the 4th power, is that less than 1 over n to the 4th, 1/4? And so we get n to the 1/4 is less than n plus 1 to the 1/4. So yes, so this converges. Now, to determine if it converges absolutely or conditional, we ask ourselves the question, would 1 over n to the 1/4, would this converge or diverge? Well, it's a p-series, and p is less than 1, so this would actually diverge. So the only reason that this is converging is because it's alternating. If it were without the alternating part, it would have diverged, so therefore this converges conditionally. Because the only reason it's converging is because it's alternating. Under normal circumstances, 1 over n to the 1/4 would diverge. So then we say it converges conditionally. Okay, so once again, this sign, this actually causes this to diverge. Why? Because 2n minus 1 will always give us odd numbers. So when n is equal to 1, I'll just put it in here. When n is equal to 1, I get 2 minus 1, which is pi over 2. And the sign of pi over 2 is 1. When n is equal to 2, I get 4 minus 1 is 3, so I get 3 pi over 2. And the sign of 3 pi over 2 is negative 1. And that will continue. So when n is equal to 3, I get 5 pi over 2, and that will give me 1. The sign of 5 pi over 2 is 1. And then when n is equal to 4, that will give me 7 pi over 2. So that would be negative 1. So this sign, this whole thing causes it to alternate. So we know the limit, so we know it's alternating. We know the limit as n approaches infinity of 1 over n is 0. And we know that 1 over n plus 1 is less than 1 over n. So both conditions are met, so this converges. Now the question is, does 1 over n normally converge? No. 1 over n is a p-series, and this diverges. So we can say that this converges, once again, conditionally, because the only reason it's converging is because it's alternating. Because 1 over n, left to its own devices, would diverge. Okay? So this is your homework, and we will work on more of this tomorrow. Have a good afternoon.